Welcome to this first MathSim video about integration. Let's start right away. Integration is the inverse operation of differentiation. When you differentiate a function f(x), you get the derivative f prime x. If you were to integrate this derivative, so to perform the inverse operation on it, you would end up again with the original function f(x). You call the result of an integration a primitive function, or just a primitive. If you want to determine the primitive of a function, you can write this down as follows. You start with a so-called integral sign, then the function f(x), and you end with dx, which is called the integration element. You pronounce the integral f(x) dx, and the result is a primitive function usually denoted by a capital. Let me show you an example. Consider the function f(x) equals x to the power 4 for which you want to determine the primitive. You write this down as x to the power 4 dx preceded by an integral sign. Then you start thinking really hard, and after some time you will probably come up with 1/5 x to the power 5, because if you differentiate this function, you get x to the power 4. But you also could have come up with 1/5 x to the power 5 plus 3, because the derivative of 3 equals 0. Or you could have come up with 13 here. In general, you can say that you can always add a constant k to a primitive. You've just seen one of the main rules in integration. That rule is, if your function is a power function, x to the power n, then the primitive is also a power function. The power of the primitive is one higher, n plus 1, and you also have to divide the result by this n plus 1. And don't forget to always add an integration constant k. Another important rule is the following. If you want to determine the primitive of a function preceded by a constant a, you are allowed to bring the constant in front of the integral sign. So this here becomes a times the integral f(x) dx. Here are some examples. Suppose you want to integrate the function 8 times x to the power 3. You write this down as integral 8 x to the power 3 dx. You know now that you can bring the constant in front of the integral sign, so you don't have to integrate it. For x to the power 3, you can use that important main rule, which makes it x to the power 4, preceded by 1/4, the same 4. Multiply this by this 8, and don't forget to add the integration constant k. You can rewrite this as 8/4 equals 2 times x to the power 4 plus k. Okay, another example. Here you want to determine the primitive of 6 divided by x to the power 4. You can bring the 6 in front of the integral sign and write 1/x to the power 4 as x to the power minus 4 in order to be able to apply that important main rule. So this gives 6, nothing happens to that, times important main rule x to the power minus 3, 1 higher than minus 4, and you also have to divide by minus 3. Plus of course the integration constant k. You can rewrite this as 6/minus 3 equals 2 and x to the power minus 3 equals 1/x to the power 3. So finally it looks like this. If the function you want to integrate consists of a sum of functions, you may integrate these functions separately. Wait, I will show you. Suppose you want to determine the primitive of this rather impressive looking function here. Then you can split up the integral into the sum of two integrals. First, the integral of 8 times x to the power 3 plus the integral of 6 divided by x to the power 4. You probably recognize these integrals from the previous examples. The first one gave 2x to the power 4 and the second minus 2 over x to the power 3. Both integrals require a constant that you may sum up to 1. Quite originally, you may call this constant k.